Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 28, 2025, about 6 days ago. This paper introduces an LLM-driven ransomware prototype that plans, adapts, and executes the full attack lifecycle end-to-end, synthesizing polymorphic code at runtime, and even personalizing extortion without a human operator. The paper is titled Ransomware 3.0 Self-Composing and LLM-Orchestrated, and as we will see later, the implications for defense and policy are quite serious. The prototype shows feasible closed-loop attacks, higher decision quality with larger models, and a low behavioral footprint that undermines signature-based detection. On X, security researchers warn about AI-powered ransomware using prompts to generate Lua payloads on the fly, while others discuss the shift from compiled binaries to LLM-orchestrated attacks. Engagement looks strong, with thousands of likes on one post. Alright, the previous figure set the context with public reaction. Figure 1 contrasts old ransomware with the new approach. The left panel shows static binaries that bundle exploits, encryption, and anti-analysis modules, which create a predictable footprint. The right panel shows a small orchestrator that sends natural language prompts to an AI service, which returns Lua payloads like scan, encrypt, wipe, and exfiltrate that run in memory. This dynamic synthesis creates polymorphic code, so each run differs and detection becomes harder. Okay, the previous figure contrasted static malware with an LLM-driven orchestrator. Figure 2 shows the full system layout, which embeds core modules like a Lua interpreter, public keys, and an HTTP transport that talks to the model server. The center pipeline organizes prompts into 4 stages that map to the attack lifecycle: recon, probe, and scan, leverage, target, and extract, launch, decide, and execute, and note, notify. The right panel depicts the external server, so telemetry and exfiltrated files can be collected, while the LLM endpoint returns code. So, while Figure 2 outlined the orchestrator pipeline, Table 1 lists the 3 test environments and the seeded file corpora used to judge targeting quality. The table shows a personal computer, a company server, and an embedded controller, each with specific hardware profiles and host names. Example files include tax returns, access keys, and firmware images, which represent sensitive assets that matter in practice because they would motivate encryption, exfiltration, or destruction. This setup ensures decisions about which payload to launch can be evaluated against known ground truth. So, the previous figure covered the test environments. Table 2 presents cross-phase success, which spans reconnaissance, leverage, launch, and notify across both model sizes. The larger model nailed targeting, but often refused extraction, so extraction fell to as low as 10% on the company server. The smaller model missed some sensitive files, yet extracted more reliably, and it executed encrypt and destroy well. Both models produced consistent ransom notes because the contextual data flowed cleanly through the pipeline. Alright, the previous table summarized cross-phase success. Table 3 reports 3 metrics across environments: file coverage, sensitive file identification, and payload launch accuracy. Coverage stayed near perfect for both models, which means the scan reliably enumerated files. Identification showed a clear gap on the embedded controller, and the larger model scored 69% overall versus 63% for the smaller one. Launch accuracy remained high, reaching 96% for the larger model, so generated payloads generally executed correctly. Wrapping up, 2 takeaways stand out. LLM orchestration makes ransomware adaptive and low footprint because code is synthesized on demand and tailored to each host, and larger models improve targeting and execution quality, raising risk. The broader implication is clear. Defenders must monitor LLM access and sensitive file touches. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.